Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 2, Chemical Foundations Part 2. Here are our objectives. Since this is the second video, I will remind you that you do not have to write down the objectives. I don't know if I said this in the last video, but where it says suggested practice problems, those are typically what I assign as the problem set, but sometimes I shorten them or add an additional problem. So still be checking Google Classroom, even though it's 99% chance that the practice problems listed here will be the problem set. And also where it says suggested reading, that's really just if you're having trouble with this after having done the problem set, unless you're somebody who really enjoys the way that this book is written. But I do find that most students don't tend to do the readings, and that's okay for this particular subject. Pause here. So now we're going to talk about significant figures. I just want to be clear that significant and important are not the same thing. Significant figures are everything that are measured, so those include certain and uncertain digits. What they don't include would be placeholder zeros. For example, if I start with 3 kilometers and then I convert that to meters and it becomes 3,000 meters, those zeros just came from the unit conversion. And so we want to, for this video, our goal is to just figure out how many significant figures there are in a measurement such that we can apply that information to some lab skills that we'll be doing later on. Pause here. All right, so I'll break down these rules. So anything that is not 0 is going to be significant. So for example, if I have 5.512 inches, that has 4 significant figures because I've got 4 digits that are not 0. Then there are 3 types of zeros, and one of those 3 has two components to it. The first type is a leading 0. So if I have 0.00052, those are leading zeros. They are not significant, so this has 2 sig figs. Then we have captive 0. So if I have 5005, so if you have a 0 that is between 2 significant figures, those are significant. So this has 4 sig figs. And then we have 2 types of trailing zeros. So the first would be trailing after a decimal, so 1.0, for example. If you have to have something before the decimal, you can't just have 0 point, because sometimes people get the leading and the trailing after a decimal confused. This has 2 sig figs. And then trailing zeros before a decimal. So if I have 55,000, those zeros are trailing after a decimal. So these are going to not be significant. So this is 2 sig figs. Sometimes you're going to need to show that a 0 is significant. So the way that you do that is by putting a bar over it. Shows up kind of weird in Google, so that's why I'm putting spaces between it. So if I put a bar over it, it means 0 is significant. So this is 2 sig figs. Another way is you could put a dot next to it. That only works if the 0 is in the ones place. It shows that that 0 is significant, which makes the 0 between the 5 and that 0 a captive 0, so it's also significant. So 3 sig figs. And then if you have a constant, so let's say I've got 45 pi, that pi doesn't impact anything. That's 2 sig figs. Let's take a look at an example. So pause here and take a minute to try it. So I will work through this. So 12.00, this has 4 sig figs. The 1 and the 2 are obviously significant, and then we have trailing after a decimal. B, that has 1 sig fig. C has 2 sig figs. And then D has 2 sig figs. So the zeros that leading up to the 4 are leading, they're not significant. The 0 afterwards is trailing after a decimal, so it is significant. Right, let's take a look at another example. Pause here and go ahead and try this example. Right, so the first one has 3 sig figs. The ones to the left of the 1 are leading, and the ones after are trailing with a decimal. 480 has 2 sig figs. That 0 is trailing with a whole number. 480 dot, that dot shows that that 0 is significant, so that has 3 sig figs. And then the 50000, that has 4 sig figs. The reason why is because the bar over that 0 makes it significant, which makes the zeros between the 5 and the 0 with the bar also significant since they're captive, and the one to the right is trailing with a whole number. Pause here and take a moment to try this. So this is actually typically how we have to apply sig figs, rounding measurements, or not really measurements, but like compound measurements to a certain number of sig figs. For example, if you're doing like density calculation and you need to take whatever number you get, your calculator might give you like 0.33333333, but you're only allowed to have a certain number of sig figs. That's where this has applications. So for the first one, for 1 sig fig, it is just 100,000. Or if you wanted to do it in scientific notation, that would be fine too. It's sometimes easier to do it that way. For 2 sig figs, 130,000, or 1.3 times 10 to the fifth. Either way is fine. There's not a better or worse. And then for 3 sig figs, I have to put a bar over that 0, which actually is a time that doing it in scientific notation is easier. Everything in scientific notation is significant. For 4 sig figs, I just need to put a bar over the next 0. And then I think it asks for, yeah, and then for 5 significant figures, very similar thing. I just put the bar over the next 0. And that is all for tonight. Thank you so much for watching and have a great night.